Hi class, we're looking at lesson 8.5, division properties of exponents. Our objectives are going to be to divide powers with the same base and then raise a quotient to a power. Here's the one thing I want you to understand. Just because I'm giving you a division rule now does not mean anything that we've already learned does not still apply. The other thing is you can't survive without the division properties because we've already talked about how the negative exponent is in the opposite or the reciprocal portion of a fraction. So there are multiple ways to attack these problems, and if you want to apply the division powers, great. If not, think. Remember, when in doubt, write it out. Okay, so here we go with the rules. In this case, we have for every non-zero number, a, integers m and n, okay, so a to the m divided by a to the n. We're just going to take a to the m minus n. We're going to subtract those, okay? And if we have a fraction raised to a power, we can, okay, right here, we can take and get a to the n over b to the n. So we can distribute that to both pieces of the fraction. No big deal. Let's simplify this first expression here. We have p to the third over p to the negative 3. So if we apply this rule, that's going to be p to the 3 minus, and we've got a negative 3 here. Okay? And then we have j to the negative 4 minus 6. When we simplify those, we get p to the 6th, j to the negative 10th. And then, again, we don't like negative exponents, so we rewrite that in the denominator without the exponent. That's using our rules. Now, if I were solving this problem, I might not necessarily use the division powers. I would look at my negatives and I would start to move things from there. So if we look at the problem again from a different perspective, we are rewrite it with positive exponents. P to the third stays. J to the negative 4 comes down to be j to the 4th. P to the negative third comes up and becomes p to the positive third. J to the 6th stays in the denominator because it doesn't have a negative exponent. So we move this up, this comes down, and they lose their negative signs. We now have our powers here, and we can follow our rules that we learned about when multiplying with the same base. That becomes p to the 6th, and we can add those here, and that becomes j to the 10th. So you can see here how we have the same answer, just approaching it a little differently. All right, applying division properties of exponents. Again, the same rule is going to apply. So in this case, we're going to take our 64 million beats per year, and there are 530,000 minutes in a year. So what is the dog's average heart rate in beats per minute? This is how many beats a dog's heart beats in a year. There's how many minutes are in a year. So if we divide, we can get our how many beats per minute. Now, with our exponents here, we can use that rule that we just talked about up at the top and subtract, and we get 10 to the third. 6 minus 3 is 3. Then with our calculator, I don't know how many of you can take 64 and divide it by 530 in your head, but you get the decimal 0.1207. Okay? If this were me, we would then write this in scientific notation, but standard notation is probably going to work just fine here. We move the decimal over 1, 2, 3, and that's about 120.7 beats per minute. Okay? Now with our quotients, raising a quotient to a power, Okay, again, following our rule, we're just going to have 3 to the 4th over y to the 3rd to the 4th. Now 3 to the 4th means 3 times 3 times 3 times 3, which is 81. Y to the 3rd to the 4th power becomes, we use our multiplication there, y to the 12th. Again, when in doubt, write it out. 3 over y to the 3rd times 3 y to the 3rd times 3 y to the 3rd times 3 y to the 3rd. How many 3's do I have in my numerator? 4. 3 times 3 times 3 times 3 is still 81. 3, 6, 9, 12. Okay. When you're done with this, go ahead and try the quick check problems. I will go over the answers. Remember to pause it, take the time to try the quick check, send me any questions that you may have. Again, with our division rules, we're really not doing anything different. It's just a different way of looking at the problems. All right, so quick check here. Quick check 1 is 1 over b to the 5th. B is 1 over a to the 2nd, b to the 2nd. C is n over m to the 4th. D is x, z to the 7th over y to the 5th. With our quotients, I reduce here. 2 eighths becomes 1/4, and then I get 10 to the negative 5th, or 10 to the 5th in the denominator. I convert my 1/4 to 0.25. I still have it times 10 to the negative 5th now. And then this becomes 2.5 times 10 to the negative 1 times 10 to the negative 5, which I get 2.5 times 10 to the negative 6. Go ahead and punch that into your calculator too. It's really important though, when you're punching something like this into your calculator, make sure you use parentheses around the entire numerator and parentheses around the entire denominator before you do the division, or it will not give you the same answer. All right, for B, this is a great example of using our properties and our rules and not having to use the calculator. 7.5 divided by 2.5 gives us 3. We can reduce that right away. And then using our rules here, we can subtract. We get 10 to the 16. So there, we didn't have to grab our calculators, and it was a great example of how we can use scientific notation and our division rules to make things go a little quicker. In our application problem here, we have the total amount of glass recycled and the U.S. population. When we use our division here, we end up getting 0.00959, and that is rounded, and then writing that in scientific notation. So each person is not recycling a full ton. That's what that tells us there. Moving on to the third, again, fractional power, 9 over x to the 4th. Here we simplify this to x to the 3rd over y to the 6th. T to the 14th over 3 to the 6th. And I'm going to leave that just like that. Be careful that you're watching your signs, and as always, when in doubt, write it out. All right. We are looking at simplifying some fractions here that have negative exponents. Now, it's up to you how you do these problems. There's multi-steps. You could try to do it in as few steps as you can. But again, think about what you have here. We have this negative exponent. We can distribute it using our rules. That gives us 2 to the negative 3rd over 3 to the negative 3. Because each of these has a negative exponent, we want to get rid of that negative exponent right away. So we're going to bring the 3 to the negative 3 up and make that 3 to the 3rd, and 2 to the negative 3rd comes down to become 2 to the positive 3rd. We can then simplify that out, and we've got 27/8. Let's try it again, and I'm going to show you. Now, notice there's a negative sign here, okay? That's going to be a little bit of a trick. What I want you to do is make sure you put that up with the 4. Now, I'm going to do this problem a little differently. Instead of distributing, what I want to do is I'm going to take that negative sign, I'm going to flip this entire fraction over and take away the negative sign. And now I'm going to square everything inside here. Again, you can think about it as c to the negative 4b times c to the negative 4b. See what I'm doing there? Negative 4 times negative 4 is positive. It's really important that you understand that. If this negative sign way over here were outside the parenthesis, that would change the sign of this completely to a negative. Okay, so please be aware of that and the location of your signs and your parentheses here. Go ahead and try the quick check. Check your answers when you're done. If you've got questions, please email me, write them in your post-video check, or ask in class. So our quick check, we've got 64/27, negative 32. It's really important. It's a negative there. S over 2R. See how it just flipped everything over with that negative 1? Kind of cool. And then the negative 2 here, we have m squared over 49a squared. As always, have a great day.